One of the big changes actually that's happened in teaching quantum mechanics in universities over the last few decades is that it was always, when I learnt it, so back even in the 1990s, it was common to teach it historically. So you go through the things that we've talked about. You go through the photoelectric effect and the structure of atoms. You get to Niels Bohr and his early explanations of how atoms might work, following on from Ernest Rutherford in Manchester detecting the atomic nucleus. And so this idea that an atom is a nucleus, a dense positive charge. It wasn't known exactly what the structure was at that time, with electrons, let's say, orbiting, in inverted commas, around it, so that there's a picture of almost like a solar system. But it was known that doesn't work because you have charged particles moving in the vicinity of other charged particles, and that means that they radiate and they would not be stable. And so there's all these things going on, confusion. And then Bohr suggests that electrons can only take certain energies, which we now call orbitals, around the atomic nucleus, and all this stuff is going on. And it used to be that we would teach it like that in university. But if you do that, you pick up all the confusion, the confusion, decades and decades of confusion that these great physicists felt in trying to come to terms with this counterintuitive picture of the world. So now, I think it's more common in universities to start with the theory as we understand it today and just say, well, this is the way the world works. And perhaps the best introduction would be to think of a property of particles called spin.